Okay, we will start to revise topic 17, which is the hydrogen peroxide experiment for Form 4 Chapter 7 reactions. So for the energy profile diagram, normally in SPM or in school exams, when come out hydrogen peroxide experiment, normally they'll require you to draw the energy profile diagram. So bear in mind that normally for real reaction, the energy profile diagram that required to draw will be exothermic reaction, because all the reaction in real reaction like hydrogen peroxide, decomposition of hydrogen peroxide, acid plus metal, acid plus marble, and then sodium thiosulfate plus the sulfuric acid is all exothermic. So exothermics, right? Because due to release heat energy, so the energy contained will drop because all the heat is released out, so energy dropping. So after that, the purpose they ask you to draw the energy profile diagram is because they want you to show with catalyst and without catalyst what is the difference. So with catalyst, the activation energy will be lesser. Without catalyst, the activation energy will be higher. So it means something like without energy, just like rolling a ball, that if without catalyst, right, you need a lot of energy to push the ball to the highest point, then only the ball will start to roll down at least. Then with catalyst, right, it will give you a shortcut that you don't need to roll the ball, so much energy to roll the ball, then you will easily release the energy. So this is the main. Then after that, if really came out K-bar question, like example, but when this question came out, it must related to Form 5, Chapter 4, which Form 5, Chapter 3, which is thermochemistry. That they came out a reaction which is endothermic. Now for endothermic, right, because it absorbs energy, so absorb energy means it will absorb heat energy. So when you absorb energy, your energy go up. This one going up like this. Then after that, with catalyst, of course, you'll be lesser here. Without catalyst, you'll need more activation energy to start the reaction. Okay, so so the idea of the activation energy is that this. Okay, so you go through. Okay, for a reaction to occur, right? This is the idea. Okay, let's say I have a hydrogen. Then I have a chlorine. Okay, now in order to have for reaction to occur, right, first the particle must collide. So when they collide, right, if they just collide normally, it means they collide lightly, not lower the addition energy, they will just bounce back without have any chemical reaction. In this case, we call this as collision. It is the normal collision. Okay, so then after that, when you in order to have effective collision means successful collision. Now, for effective collision, in order for this to happen, right, first you must collide. Okay, we look at when does it happen. That first you collide strongly, that it will form what we call the new chemical bond, or as you know that what we call the covalent bond. They actually sharing electron. So imagine now if you what we call the heat strong enough, right? Then the shell will able to wait, first I redraw this thing first in order to have a better picture. So we draw a full circle. Okay, this is the original bond. Then we have the same thing on the other side. Okay, so look at here. Now, in order to have the chemical reaction occur, first you must collide very strong enough so that they form a brand new covalent bond. Then after that, they only break down back to the HCl. In this case, they were able to form HCl. But so in order for this to happen, first condition that you must be more than activation energy. So must be strong enough so that you form new covalent bond. If like very lower the addition energy, they will just collide and then bounce back. So this is the first idea, the first requirement. Second one must be correct orientation. Correct orientation means the way they collide must be correct. Like example, if you collide like this, it won't happen because you can see this one have reaction. They're able to form new bond, but for the other H and the other Cl does not have any contact. So it won't able to have any reaction. So in this case, right, like this, nothing happened, nothing happened, nothing happened, nothing happened. But this one, something happened. So you see, in order to have what we call effective collision, right? First, you must be more than addition energy. Second one is must collide at the correct orientation. So this why later when we talk about collision theory, right, you always have to mention about frequency of collision increase, then frequency of effective collision increase. It's like if you collide 100 times, successful collision maybe is only one. But if you're able to increase the collision into 1,000 times, of course, the successful collision will relatively increase as well. So like 100, one time successful, 1,000 will be 10 times successful. Okay, so this is the first idea lah. So when you're able to lower down the activation energy requirement, right? Although the collision remain the same, but able to increase the collision maybe 10 times if you lower down the requirement, because it's just like some example, like let's say I always give example to my two students that in one class you have 40 students. Okay, you have 40 students. So if the requirement to get A in chemistry is 70 marks, example lah, then we have maybe 5 students able to get A. So, but if I lower down the requirement, like the activation energy now, I lower down to maybe to get A, I lower down to maybe 50 marks. In this case, maybe we have 30 students able to get A. The number of students still remain the same. Okay, the number of collisions still remain the same, but the successful collision, the successful students will increase due to the requirement come down. Okay, so this is the idea. So when we mention about let's say in this case that hydrogen peroxide, you need a manganese 4 oxide as a catalyst. So when you use manganese 4 oxide as a catalyst, right, they'll provide a shortcut to which require lower addition energy. This lower addition energy is just like from 70 marks, I drop down to 50. So when 50 marks, right, more students were able to get A, but the number of students still remain 40. Originally, maybe only 5 students get A, now become 30 students get A. It's because the marks go down. So in this case, you're not allowed to write frequency of collision increase because frequency of collision remain the same. The number of students in class still the same. But because the requirement come down, more students get A, so more particles successful. So more particle able to achieve the lower marks from 70 now, lower down to 50. So successful get A students will increase. So bear in mind on this idea. So for decomposition of hydrogen peroxide, right, you have to know that the hydrogen peroxide, when you just leave it there, they'll decompose to form oxygen gas, but it's very slow. It's just like Coca-Cola, they leave it there. It will form some bubble up, but it's very slow. But if the catalyst is like the Mentos. When you add Mentos inside, you suddenly see Coca-Cola will come out a lot of bubble. Yeah, okay, so the Mentos will be the catalyst for the Coca-Cola to release the carbon dioxide gas. Okay, so this is the draft idea. Of course, the more Mentos you put will be will be faster the reaction because due to the more catalyst. Of course, you increase a little bit. That's why 0.2 gram will increase, but it won't be like sudden increase a lot. Like they say you do 3 times. Okay, from 0.2 to 0.6, 3 times the catalyst, but maybe increase of the reaction rate increase in the 20%, 30%. It's not like 3 times as well. Okay, so now after you understand this one, then we go through questions. Okay, the idea is like this. For these revisions, right, you're able to download the PDF file. So you print out the exercise. So it will be 5 exercises for each topics. So these topics, right, the idea is like the first question I will teach you how to do, then what is the proper answer. Then second question we repeat one more time for you to see actually it's a similar question, but the way they ask slightly change. Then after you copy the answer for first 2 questions already, then the third question, fourth question, and fifth question, please try to do it by yourself. That you memorize back the answer in first question, second question. Then third question, try to without refer to the answer. Maybe you can pause the video first. Then after that, you can try the question. Then after that, you complete it. Okay, maybe part A, part B, part C got 6 parts. Maybe you know how to answer 4 parts. It's okay. You just try to do it by yourself. Then after that, assuming you are in exam, after that you finish it. Then you play the video. Just like you pause the video, then you start playing the video, and then you check the answer one by one. Then use a red pen to mark the paper. So the third question is like, after you copy answer, you really sit in exam. Then after that, maybe 10 marks, you're only able to get maybe 5 marks. It's okay, but when you mark the paper, you know your weakness. Then the fourth question, you start to try one more time. Maybe the fourth question, you get very good result, you get 8. Then the fifth question is slightly caveat a bit, because I can't give you the same question because it won't be helpful. So I try to change a bit caveat. A bit caveat is like that maybe has some diagram, maybe related to daily life. Then you try to answer one more time. Then because it's the 5th time, when you're able to get 10 marks means when you enter your school exam, you should be able to get very good results. Okay, so there's 5 questions every subtopic for you to train up yourself. So the first 2 questions you can listen, and then you try to copy out the answer and then memorize the answer. The 3rd question, 4th question, and 5th question are very similar questions. And then you try to do it by yourself. Do it once, 3rd question first, then play the video again, then pause the video, try question 4 again, play the video again, then pause it, then do question 5 by yourself one more time to make sure this time you can get 9 or 10 out of 10 marks. Then you can move on to the next topic. Okay. Now definition, you know, for this chapter, the one that always come in exam, it will be 2. Okay, one is the catalyst, one is the rate of reaction that came out in SPM before. These two what we call the definition. So you write down the definition. This one definition is from the textbook. So what is catalyst? Catalyst is a chemical substance that can alter. Remember, you only can write alter the rate of chemical reaction, because alter means you can increase the rate of reaction, you can decrease the rate of reaction. If you increase the rate of reaction, require as positive catalyst. If you decrease the rate of reaction, require as a negative catalyst. Okay, so you must write alter, you cannot write increase. Study is a common mistake. Students, they thought that our catalyst must increase rate of reaction. Okay, then what is the chemical equation for this? For hydrogen peroxide, when you heat it, or when you just leave it there, you slowly become water back and then oxygen. Okay, then after that we will balance this equation. So to balance this equation, we try to do it here. H2 balance, 2H, then here got 3H. Then we start there. So I told you before, whenever you start there, because this is 2 hydrogen, 2 oxygen, here got 3 oxygen. So you start there because all of them got oxygen, then you don't know what to do. When you don't know how to do it, find the longest one times 2. So in times 2, this one will be 2. Then after that, we check again, 4H, 2 times 2 is 4 hydrogen, 4 oxygen. Then here got 2 oxygen, here got 2 oxygen, so the equation is balanced. Then after that, okay, this is the one that explain how it can alter the rate of reaction. So we will try to explain it. So first thing, you must mention about the manganese 4 oxide. The manganese 4 oxide. You can see when you add manganese 4 oxide, right? The reaction will increase. But of course, in this case, you have to know that experimental will be much more faster than number 1, because for the Coca-Cola, without catalyst, the bubble come out is very, very slow. But when put the Mentos will be much more gas released. Okay, so you must mention that the manganese 4 oxide will provide a shortcut, we call it alternate pathway, which require lower addition energy. Then after that, more H2O2 molecules will be able to achieve the lower addition energy, means the marks gone down from 70 to 50. Okay, then frequency effective collision between the hydrogen peroxide molecule will increase, then rate of reaction will increase. Okay, I underline the words means it's the chemical name. So whenever your school teacher change the chemical, you can just use exactly the same sentences, alter it to another chemical name. Okay, so suggest two other methods to increase the rate of reaction. Okay, in this case, right, to increase other rate of reactions, right, this is the shortcut I teach you. So first thing, we have solid, we have liquid, we have gas. So for solid, you can increase decrease the size. Liquid, you can increase the concentration. Then gas, you can increase the pressure to increase the rate of reaction. These 3 can use common factor of temperature. Then catalyst is another one. So in this case, we only have hydrogen peroxide, which is liquid. So you can increase the concentration of the hydrogen peroxide. You can increase the temperature. So when you mention, right, because they're asking method, they're not asking factor. Factor, you can write temperature of hydrogen peroxide solution. But method means how do you increase? So you must say heat the hydrogen peroxide solution to increase the temperature, and then use a higher concentration of the hydrogen peroxide solution. Then, as I told you before, they always ask you to draw the energy profile diagram. This is what you should be able to draw it, which is you must show that number one is without catalyst. You can see number one without catalyst, you need higher activation energy. Then number two, you'll need lesser, smaller activation energy. So this is the graph you have to show that. Okay, then we look at second question to see what is the difference. Hydrogen peroxide decomposes slowly at room temperature to produce water and oxygen. So the decomposition is catalyzed by small amount of manganese oxide. So you can see this is the manganese oxide. Both have manganese oxide. Then after that, this one is 0.1 mole and 0.2 mole. So write the chemical equation. So it's the same in previous one. Then manganese oxide is added as a catalyst to speed up. So explain how this manganese oxide able to increase the decomposition of hydrogen peroxide. Is exactly same answer we just now. Okay, that's why I say that the first question, the second question, I will show you the similarity. Then after that, the third question, fourth question, fifth question, you try to practice until you're able to score. As I told you that you need to master every topic. Okay. In deep to enable you to what we call answer the keep-up question in SPM, even in school exam. So try to memorize the answer for the first two questions. Okay, other than catalyst, what can you use? As I told you, can increase the temperature. This is fractal. So if method, you must mention how you carry out, you heat the hydrogen peroxide solution. If factor, just write temperature of hydrogen peroxide solution is enough. Okay, calculate the maximum volume. Okay, sometimes for reaction, they like to ask for what we call the calculation. So they want the calculation for this. So we look at what we have now. We have this. This is our V. This is our which experiment they want? They want experiment 2. So we look at experiment 2 lah. So V and M. So this is my volume. This is my molarity. So first you add inside to find the H2O2, the M and V 0.2 and 20. Then after that, you'll get what we call 0.004 mole. Then you look at, in this case, look at the ratio. The ratio is 2 to 1. So 2 to 1, if I have 0.004, I will have half. Okay, but you must written in the sentences, the ratio method. So 2 mole H2O2 will produce 1 mole oxygen. So 0.004 will produce 0.004 divided by 2, 0.02. Then once you have 0.02 mole of oxygen in it, so you convert it into volume. Convert it into volume. Then molar volume is 24. Then you're able to get 0.048 dm³. Okay, sketch graph for number 1 and number 2. So this one, they need you to sketch a graph for number 1 and number 2. Of course, number 2 will be faster, and the height of graph will be double as well, because the hydrogen peroxide they use actually is double. The number more is double. So you have in this case that the first one here is 0.04 mole. Then another one is 0.1. Then 20 divided by 1000, then here is 0.002 mole. So because hydrogen peroxide, the height of the graph depends on the mole. 0.004 mole of H2O2 will produce double the height, means it will produce double the product. It's just like if you burn 1 paper, it produces 20 cm3. If you burn 2 paper, of course, it will produce 20 times 2, 40 cm3 of carbon dioxide gas. Okay, so the more chemical you burn, the more chemical you use, there will be more product will come out. Double will be double product. Triple will be triple product. Okay, so please pause the video now. Try this question by yourself. Okay, so please try. Then once you finish reading, you just try whatever things that you're able to answer. Which question you can answer, you just answer it. Then after that, only you play this video to continue play this video to check the answer. Okay, so I give you normally for one structural question, you need about 5 minutes, 5 minutes to complete, 5 to 10 minutes to complete. Please try it. Okay, so we look at the gas come out. Slightly change a bit, you need to write oxygen gas. Chemical equations, same chemical equation. Experimentation higher rate, you see, this one have more catalysts. So of course, the reaction will be higher. Lah. So the mass of the catalyst manganese 4 oxide will be higher. Then after that, stick two characteristics. Okay, for catalysts, right, you have to know about this thing. Okay, we only need very small amount of catalyst. This is like our enzyme in our body because we don't need so much enzyme. We need a little bit enzyme because enzyme can reuse. So catalyst also can reuse. So no need like a lot like this. Then it won't take part in the chemical reaction. So means after reaction, for example, let's say I put iron as a catalyst, right? At the end, it's still iron. Chemical, it won't change. And then very specific, like the enzyme, this enzyme for protein, the enzyme for catalyst, for carbohydrate like this. Then for chemistry, it's the same thing. This catalyst is for this reaction. You cannot use another catalyst to put in this reaction, it does not help. And then catalyst might change physically, but unchanged chemically means, example, if you put iron salt inside, maybe at the end of the reaction, it might change physically. Chemically, no change, still iron. Maybe from solid, it turned into powder. Okay, one of the example. Then draw the energy profile diagram. So it's the same lah. Experiment 1 will be need more, than experiment 2 is lesser. It's because it has more catalyst, so activation energy will further go down. Okay, so you try question 4 by yourself one more round. Question 4 is slightly a bit key, but you try first. Because you have to try to face the question first, then I explain to you later. Okay, please try. Okay, good. So these are questions from state people that it come up some keyword that they actually link the hydrogen peroxide with chemical chemistry and bio. So hydrogen peroxide, they mentioned that is in our cell. So this cell will produce enzyme catalyst to remove the hydrogen peroxide. So this one, the enzyme catalyst is in the label, can alter rate of reaction. It doesn't mention to you it's increased rate of reaction or decreased rate of reaction. So whether it's increased, decreased, you look at what is the effect. This one is without catalyst, but this one is with the enzyme. You can see very obvious the bubble increase. So it actually is a positive catalyst that increases rate of reaction. So this is the equation. Then the function is as a positive catalyst. So positive catalyst provide alternative pathway to which require low activation energy. More colliding hydrogen peroxide molecule will achieve the low activation energy. So frequency effective collision between for frequency of effective collision, because due to only got hydrogen peroxide, so it's hydrogen peroxide collide with hydrogen peroxide. Then draw the energy profile is the same question. Then you try the last question for this. This also is a K-bar question. You try to explain. Good. So now this one is slightly K-bar. The way they ask is a bit different. How do you able to follow up this experiment? So they put enzyme A and enzyme B. Then this is the result. How do you measure this gas? How do you collect the gas? So they can use gas string. The volume of oxygen gas evolved can be collected and then measured at a fixed interval. Maybe every 20 seconds, you look at the gas release. Then what is the effect of this thing? So you can mention they actually both are positive catalysts. Then after that, they, of course, enzyme A were able to increase more than enzyme B. Then you look at here, got a special question. Why without catalyst, the reaction is so slow? So it's actually a K-bar question. When without Mentos, the Coca-Cola will produce bubble very slow. Why this happened? But when Mentos, like a lot come out. So you can think about this idea, but they will give you a clue. It's a K-bar question, but they give you a clue that activation energy. Talk about activation energy. So when no enzyme, very slow. When got enzyme, very fast. What do you think? With the activation energy means the activation energy must be very high, very high. That's why without catalyst it's very hard to react, but with catalyst will be very fast. Okay, then after that it's repeated with enzyme B. This time they use the same volume hydrogen peroxide, but half of the original. So you see, the concentration will decrease, right? When you use half of original. Okay, so of course you'll be slower, and then the height of graph also will be lesser. Okay. Then after that, okay, that's it. So you can continue topic 18.